Thank you all for joining in to our first Tech Talk. It's my pleasure to be here with you. I look forward to the next half an hour. We'll take those 30 minutes. There are a few things I want to show you and I want to discuss and talk about. The session will last half an hour. I'm going to present for 20 minutes or so. If you've ever seen me present before, that's kind of a rough estimate. But anyway, there will be time at the end for Q&A. As Allie said, we're going to be covering the benefits of a comprehensive modeling environment. So I kind of wanted to start at the beginning. It's the best place I know to start, and discuss what we all do. And as you see here on this slide, in terms of project delivery, in terms of design, any project that we work on, it doesn't exist by itself. Roadway doesn't exist alone. It exists on the earth, adjacent to a commercial site. A bridge doesn't exist alone. It exists within the roadway corridor. The utilities, the drainage, the sanitary sewer doesn't exist alone. It exists in relationship to a parking lot, an apartment complex, a roadway, any other type of infrastructure. All of those things need to be working together. So in terms of project design and delivery, we have to evaluate and we have to be able to interact and understand all of those other parts, okay? And so that's kind of where we're going to focus today, because we're talking about a comprehensive modeling environment. Now, as I was kind of thinking about this, I kind of see it on two levels. And it breaks down to two main, fundamental concepts when we talk about a comprehensive modeling environment. A modeling environment needs to, number one, take care of the transition of data, the creation of data, necessary data within my project lifecycle. It needs to take care of creating and transitioning and using that data throughout the project lifecycle. It also needs to allow me to have design data from different disciplines interact with one. So as we move forward in the OpenRoads world into the OpenRoads Connect edition, in terms of data creation and management and data handoff in the project lifecycle, if you look here on the screen, starting at the top, we highlight applications within the OpenRoads Connect edition. Applications that span from, at the top, context capture for capturing reality, using imagery to build terrain and 3D meshes so that we're able to capture that existing condition, whatever that may be. If you follow that circle around clockwise, we move from capturing existing data and existing conditions on around through Concept Station, OpenRoads Designer, LumenRT, Navigator, and on into construction. So on the big picture level, we're talking about a comprehensive modeling environment that involves applications that work together in order to fulfill the project lifecycle. The transfer, the creation of data, useful data, whether it's the existing ground, whether it is taking that design model that we've created with OpenRoads Navigator out to the field and reviewing it in the field, seeing where our design or their potential conflicts and so forth, okay? So on the upper end, the high level application, a comprehensive modeling environment consists of applications that work together to generate data and share that data. Now, as we zoom in a little bit and we get a little more detailed and we think about a comprehensive modeling environment in terms of design, a specific project, we always have the question of what are we going to model. So in this comprehensive modeling environment that we're starting to think about, we again have to consider, what do we need to model? Do we model the roadway? Do we model the bridge, the curb and gutter, the sanitary sewer, the manholes, signage? Where's the limit? And as you look at these images, you'll notice each of them represents really a different discipline, a different group of designers within the framework of an overall infrastructure project. Any given project could have a roadway, a bridge, a rail, drainage, sanitary sewer, it could have utilities, a duct bank, and all of that involves multiple moving pieces and parts, right? So a comprehensive modeling environment needs to address that. And so my two main bullet points, I guess, as we get started is, when it comes to modeling, we need an effective way to handle data. You all know that collecting data, managing data, using data sometimes becomes quite a hurdle between transitioning different forms of data from one step of the process to the next. Okay? But on the other side, or in addition to managing that data, a modeling environment needs to provide the ability to compile data, engineering models from different disciplines so that we can see how the bridge interacts with the roadway and how the roadway interacts with the adjacent parking lot, and how the adjacent parking lot interacts with the building that's on the side, right? So let's take a look. I don't want to go to the summary too quick. All right. Hope everybody can see my screen okay. If you have technical difficulties as well, please drop those in the window, the Q&A window, just to let us know if you are having any kind of technical problems with my screen share or the sound or anything, okay? All right, so again, in context of what we're talking about, a comprehensive modeling environment. You see here on the screen, I've got a proposed site design that really is more than a site design. It comprises a lot of pieces and parts. Now, as we look at this, on the left, we have the two-dimensional model view of the proposed layout of a site with adjacent bridge, roadway next to it. On the right-hand side, we have the three-dimensional model view, that same site, okay? So how do we bring these pieces of data, all this engineering content, how do we bring it together so that we can see it and relate to it? Now, the first thing, let me look over here, pin this up here. Now, as we begin, again, looking at this site, it's not just the parking lot. So what I'm going to do is turn on several of the pieces and parts that are involved in this site, okay? So I'm going to first of all turn on the roadway model. I'm going to zoom in a little. So I've turned on the roadway itself. Zoom out a little bit. There's a railway within this site, within this model. You can see that as well. You can turn on the grading along those corridors. And then we can turn on the walls adjacent to the corridor, okay? Now, in addition to looking at this model, you'll notice that the model is broken into definable components or constructible elements, I'll say it that way, and I have the ability to turn on and modify or at least affect the display of those elements within my model. An important part of modeling, and really when we talk about a comprehensive model or a compilation of data in a model, is being able to interact with it, to be able to review it, to be able to manage it. So we have the ability, based off of these checkboxes, to turn on and to manage the display of that data, okay? So that we can interrogate the model, we can make engineering decisions. Now, in addition to turning on those 3D elements within the model, I'm going to turn on the linear elements that comprise those as well. You can see the model updating as I turn those on. Okay, so the model in this case is made up of solid elements that you see in the solid components within the model. It's also made of linear elements. Y'all know linear elements are needed so that we can measure things like stations and offsets, so that we can provide break line data, edge of pavement data when it comes to construction, those kind of things. So we see the beginning of our model. We see the roadway and the railway. So I've turned those on. But in addition to that, maybe we want to turn on some data, some external data. So what I can do is I can go and I've referenced in a bridge model. And I can turn that reference on. You can see that on the screen. Let's change the display. Another important part of when it comes to modeling is, again, to be able to interact with that data, to modify the display, to be able to rotate the view, to be able to zoom in to specific areas, to evaluate what's going on. So in this case, as I zoom in and I want to look specifically at the area between the roadway corridor and the bridge, I can do that. So simply by referencing in that bridge model adjacent to my roadway corridor, I could check the cross slopes of the pavement and evaluate if the transition's right for the cross slope of the pavement relative to the bridge deck. What do I need to do when I get to this point where the curb and gutter matches the barrier? All those type of details become evident, and they become available and easy to see and interpret for you to make engineering decisions based off of the model data. Okay, so we've got the bridge in, and again, we can see that, take a look at it, rotate the view around. I tend to like transparent views, so we'll change back to that. So we brought the bridge in. We can see that interacting with the roadway corridor. Now we can go a step farther. And I'm going to go over to the references here. And maybe I want to reference in a building, a structure. So I'm going to browse using the reference dialog here. And bear with me while I browse to the proper place. So I'm just browsing into a directory. I'm going to select the master model that contains the building model. And there's a couple of notes here when we talk about a building model versus a civil design model. And we can talk about those at length. Feet versus survey feet, state plane coordinates versus 0, 0, 0, or 10,000, 10,000. But now I've referenced in that building model. Now I'm going to make a couple of adjustments to that reference. First of all, I'm going to increase the nesting depth. So within that building model, I know that there are multiple files referenced together to make up the actual building model. So I'm just going to increase the nesting depth so that we can see all of those elements. Now, I fit the view in my 3D model. And I'm sure you all have probably seen this before where things don't align, right? Geospatially, the X and Y for the building is different than the X and the Y of the actual site in the real world. So I can handle that. Again, it's really about compilation of this data. So I've referenced that in. I'm going to jump in here. I'm going to change the model itself because I have a model built into this overall DGN, and that model has a coordinate, has X, Y, and Z values built in it, okay? And so by that, now I've changed that model. Let's zoom back over here and look at our site. Bear with me here. And now I am going to reproject that building onto my site. So an important part too when it comes to modeling and compiling data within a comprehensive model is to be able to adjust stuff geospatially. I need my state plane or I need your building to reference my state plane coordinate system and so forth, okay? So we've done that. I've referenced it in. We geo-referenced the building in. And so now we can see more of what would be a compilation of our engineering model, okay? Now, a couple of additional things to point out and to just discuss. Being able to see the data is important. As I said, being able to zoom into the area where the bridge meets the roadway and just to visually inspect whether or not the cross slopes match, even whether or not the pavement seam with the concrete bridge deck seam matches correctly. Being able to do that visual inspection and interpretation is important, and it's really invaluable when it comes down to it. Seeing is believing, right? So that's one aspect of a comprehensive modeling environment. But an additional aspect of that modeling environment is to be able to utilize that data, to be able to create from that data, to be able to have that data interact with the pieces and parts so that I can actually create something. I can design within the model, okay? So you can see a couple of things here. Number one, from that abutment of the bridge, you can see that I've placed a slope just around the abutment using OpenRoads tools. I just did a linear template with a fill slope and placed that running around the top of that abutment so that I can see that in the model. I can do things like have the end conditions around the curb and gutter interact with the terrain underneath it. Okay. I can, let's see, for example, I can place drainage structures, which is a big important thing. So let's focus on that for a minute. Now, I've put this data together. We can see it. But again, let's talk about extending and using that data with a little more purpose. So, for example, and another discipline that may be involved and that you have to consider when it comes to placing data within and recognizing what's going on within engineering context of our overall design is drainage or utilities in this case. I've set it up. I've set the place node to the water valve. Tell you what, let's do it this way. I'm going to zoom into the parking lot. Let's place some drainage. So recognize here that the terrain for this parking lot, that was constructed. Now I'm coming in, or this could have been referenced in to the drainage engineer, and they can come along now and place some inlets and a drainage network across the parking lot. So let's just do that. So I'm using the drainage tools within OpenRoads at this moment, and I can, let's just say here's a low point. I'm going to place this inlet. Okay, I'm just data pointing through the prompts. Now I can work between, notice here I can work between 2D on the left, 3D on the right, which is important when again it comes to thinking about modeling, right? 2D to lay it out, 3D to interpret it. So I'm going to, time is of the essence. So I'm going to just place this in the model. And we'll just, again, I'll do this quickly and just place that. So now we have that structure placed. Okay, so let's move on down. Let's say we want place another inlet. Zoom in and we'll see that structure being placed in the model. Now again, as we're laying this out and as we are building this, think about it in terms of a comprehensive model. A model that takes into account and utilizes multiple design elements from multiple sources. So we'll click and rotate. Again, we are moving quickly. So we see that there. And now let's just assume, for time's sake, we want to place one more and then we'll draw an outfall. And again, I'm moving quickly and I made a mistake. You can see that directly in the model. Just simply remove that. And now I can go ahead and, if I'd like, I can place an outfall node and we can connect to that. So in terms of, again, just interacting with this data, let's set to 18. I'm going to place the outfall here on the side slope. Okay. So we can see that there. And of course now, when it comes to modeling, a key element is to be able to interact and review that data. Okay? We can make modifications to the structures themselves. So we'll be able to pick up and move the structures around if we like. And then, of course, when it comes to drainage, we can connect the pipes, connect the nodes together with pipes. Pick our feature definition again that we want to use. Time is limited, so I'm not going to make this an 18-inch pipe. So now we can see that interaction of that pipe with those nodes. And again, it's all relative to the overall model that was constructed. Okay? Now, again, I said this will last half an hour, which is difficult for me to fit very much. I like to I like to talk a little bit, so half an hour, makes me focus, I guess. The main thing, I guess, I want to point out when it comes to talking about the benefits of a comprehensive modeling environment. Number one, at using various applications and differing applications as sources for data that's relevant to our design model, being able to use that and incorporate it into our design is important. Okay? That's the first thing. So we're able to see the rail line relative to the bridge in relationship to the roadway. Okay? Now that's all done based off of, there's a geospatial location to all those elements that underlies those, and that's contained, it's contained either based off the horizontal vertical alignment from which they originated or in the DGN coordinate system itself in the DGN file. Okay, so compiling that data, compiling those models to make sound engineering judgment is important. The other aspect is, and that we didn't get to cover this as much as I'd like to, is being able to interact and use that data in relationship to one another. Okay, so two aspects to that comprehensive modeling environment. One being able to compile the data, the other being able to interact with it. Now, as we move forward in Tech Talks, again, this is our first Tech Talk, and we're going to be doing these monthly, so keep your eyes out for additional Tech Talks as we move forward into each and every month. As we go forward, we're going to continue to explore these types of topics. We're going to continue to explore modeling and modeling in context of practical application to engineering design. Okay? Recognize that when we talk about modeling, and I will expand on this, and many of you may have already seen these things when it comes to OpenRoads tools and technology. The model is an engineered model. It's a model that contains your design intent, that understands that you make the decisions of how side slopes tie to one another. You make the decisions on how the slope of the pipe interacts with the inlet and so forth. Okay? So let me go back to our summary slide. So a comprehensive modeling environment really, in my opinion, allows us to go beyond modeling. And it allows us to actually design what we intend to be constructed while we're modeling. So we're creating a model that's based on engineering judgment and design intent, not just a model for visualization or animation, but it's a model, again, built off of engineering judgment and decision, okay? So that's really the main thing to get out of the presentation, I think. And when we think about modeling, again, let me just sum it all up. Modeling needs to be able to manage data, and it needs to allow you to make engineering decisions based off that data, okay? That's Joey's summary. So I know we are close to the half an hour mark, so if we have any questions, please, I'll take those. Probably ought to stop that loop. All right, let's see. A couple of questions. All right, the first, how you guys showed, or you saw how well, the question is, how did you locate that building on the site? So if we back up to that, and I'll give you just the brief points of discussion on that. Again, everything is based off coordinates. It's based off a coordinate system. So to locate that building, and y'all know that a lot of times building designers and architects work in a world of 10,000, 10,000, or an area where or in a world where the coordinate system, the state plane coordinate system, doesn't exist. So how do we make that transformation from that world to our world of state plane, lat long, real world coordinates? What we did within that building model, there are geographic tools, and these I'll give you just this tip. Within those geographic tools, number one, many of you probably have already set a coordinate system inside your DGN. You know that a DGN can literally have a state plane coordinate system, which defines the X and the Y relative to that zone within whatever state. In addition to that, in these geographic coordinate tools, you can actually use this to go into the building model itself, and this can happen on the building designer side of things, and you're able to define a known coordinate value for a building corner, or all 4 building corners, or 2 building corners for that matter. So you have the ability to coordinate your state plane building corners with the actual building model. It doesn't matter what coordinate system the building model was built in. You'll note here that I can actually select a coordinate system. So the X and the Y that's defined in the building model will be relative to my X and Y in whatever state zone I have specified, okay? So that's really how that happened. The building model has a place mark, and it has a couple of place marks in it defining that state plane coordinate. All right, I know that was a quick explanation of that, but the key is to know that those place marks are there and available to use. Again, coordinating that data is important. All right, another question, how do you turn on the display? Or how did you turn on the display of the individual elements in the model? You remember, and let me rotate things around. As I kind of got started, I went over into Project Explorer. And within Project Explorer, using the standards, and these are standards, which are called feature definitions for the elements in the model. By using those feature definitions, so for example, if I hover over that retaining wall, okay, and we take a look at that retaining wall literally has a feature name and a feature definition. Feature definition defines what it is, what it looks like, what level it's all, defines what it is. So because the model has individual componentized structural elements within it, that gives me the ability to go within Project Explorer and gives me the ability to turn on or turn off those elements independently, which gives me, again, a level of control for evaluating this model and this composite model in a way beyond just having to turn on and turn off levels, colors, and line styles and weights. This gives me, again, a true element level control of turning on and turning off certain things, okay? And so I did that simply by going to the Standards tab and turning on or turning off elements based off of its feature definition, okay? All right. Well, we're a couple minutes past the half an hour. Again, please ask questions, drop those in. I know we limited this to half an hour, so I don't want to go too far beyond that time limit. If your question wasn't answered, we will respond to those and we will follow up with those responses. So if your question wasn't answered, please, we will do our best to follow up on that question, okay? Also, too, I'd like to say, again, thank you all for joining in. We are starting the Tech Talks, and we appreciate any feedback you have as far as the ways we can improve this. Again, the Tech Talk is intended to be half an hour Q&A. We want to be topical and we want to be relevant. And we want to be practically relevant to what matters, in the real world of design. So please give us feedback as far as how we can improve or what we can do with Tech Talks. So thank you for that. And again, thank you for joining in, and I look forward to seeing you guys next month. So thank you, and I hope you all have a great day today.